right, we're going to start in your new journal, restaurant receipt cards, and what you are going to do on this, these are 4 different receipts from Alice's Diner, and they happen to leave off the little subtotals here. So all you know is that they bought 2 super sodas and 3 big burgers, and the whole thing cost $18. And we don't know how much each one of these cost. Over here, the same thing. We've got 5 super sodas and 6 big burgers, and that costs $39. And then down here, they actually have some fries added to theirs, and this all cost $18. Then over here, we've got all 4 things: monster nachos, big burgers, fast fries, and super sodas, and that costs $38. What you have to do is determine how much super sodas cost and how much big burgers cost, and etc. So they do tell you that Alice's Diner sells only 4 items which have individual prices of $2, $3, $4, or $5. So they have to cost either $2, $3, $4, or $5. Okay, so you're trying to figure out, you're going to use, I would start with these 2 up here. And you're going to have to probably use a guess and check method and see if you can figure out, it's kind of like a puzzle, how much super sodas cost and how much big burgers cost. And then you're going to try to figure out how much fast fries cost and how much monster nachos cost. So go ahead and stop the video and work on that for about 5 minutes and see if you can come up with how much they each cost. All right, what did you end up with? You should have had, after you looked at the first 2, maybe you guessed how much they cost, and super sodas cost $3, and big burgers ended up costing $4. Right? So if these cost $3, that would be $6. And if big burgers cost $4, 3 big burgers would be $12, and that would add up to $18. And then you'd want to go check over here and make sure super sodas cost $3, so that would be $15. Big burgers cost $4, and 4 times 6 is 24, and that adds up to $39. So that is probably what they cost. And then you could come down here, and you know that big burgers are $4, so 2 of them would be $8, and you know super sodas are $2. So $3, so 2 of them would be $6, and that adds up to 14, and then 18 minus 14 is 4. So that tells you that 2 fast fries cost $4, and so they must cost $2 each. So down here we'll put fast fries is $2. Okay, and then Alice's Diner sells only 4 items which have individual prices of $2, $3, $4, and $5. Oh, the same thing. Okay, so we know that big burgers are $4, so 3 of them would be $12. Fast fries are $2, so 2 of those would be $4. And super sodas are $3, so 4 of those would be $12. Okay, so that would add up to $28. So 38 minus 28 is 10. So monster nachos have to be 10, and 2 of them have to be 10. So that means that monster nachos would cost $5. Okay. Now this one was pretty simple. If the numbers got bigger or if you had more items, it would get a lot more difficult. And so we have ways to figure this out using equations. And that's what we're going to be studying in this whole unit. It's called systems of equations. Right? Using B for the cost of a burger, and F for the cost of fries, and N for the cost of nachos, and S for the cost of a soda. Write equations for each statement below. So each one of these represents one of those receipts. So 2 sodas would be 2S, and plus 3 burgers would be 3B, equals $18. Okay, then 5 sodas, 5S, plus 6 burgers, 6B, equals $39. Then 2 burgers plus 2 fries plus 2 sodas equals $18. And then 2 nachos plus 3 burgers plus 2 fries plus 4 sodas equals $38. Okay, so we can write equations instead to represent those receipts. Okay, when used together, when all these equations are used together, these form a system of equations, which is a set of 2 or more equations with 2 or more unknowns or variables. The solution, that's what goes in this blank, solution, to a system lists the values that can be used for each variable to make the equations in the system true. Okay, so this is called a system, and for example, here's another system. Okay, this is called a 3 by 3 system of equations because it uses 3 equations and has 3 variables. The variables in this one are x, y, and z. And then here are the 3 equations. Okay, this system would actually be called a 4 by 4 because we've got 4 equations and then 1, 2, 3, 4 variables. All right, now they want you to determine which one of these, A, B, or C, is actually a solution to this. Okay, so what you're going to do is take your calculator. Everyone should have a calculator. If not, go grab one. And we're going to plug in x, y, and z into each of these equations and see what happens. So we're going to do 2 parentheses, and always do parentheses for your variables. So 2 parentheses, negative 4, plus 3 parentheses, negative 1, minus 4 parentheses, 2. We'll see what that equals. Now I got negative 19, and it's supposed to equal negative 3. So these do not work in this equation, so therefore A is not a solution. Now we're going to try B and see if B is a solution. Okay, so we're going to have 2 parentheses, 9.5, plus 3 parentheses, 0, minus 4 parentheses, 5.5. Okay, this time we got negative 3, which is what we're supposed to get. Now, that does not mean that this is a solution because these also have to work in the other 2 equations. They have to work in all 3 of them, so we have to check all of them. So now we're going to check that x minus z equals 4. So we'll have parentheses for x, 9.5, minus z, parentheses for z, 5.5, equals 4. So that works. Now we have to try the last one. So we have negative parentheses, 9.5, minus 2 parentheses, 0, and then plus 3 parentheses, 5.5, and equals 7 and not 4. So it worked in the first 2, but not the third one, so therefore it is not a solution. So C should be our solution, but we are going to check it and make sure. So 2 parentheses, 5, plus 3 parentheses, negative 3, minus 4 parentheses, 1. And that equals negative 3. Okay, and then we're going to have parentheses, x, 5, minus z, which is 1. And of course 5 minus 1 is 4, so that works. Okay, and then we'll try the last one. Last one, negative parentheses, 5, minus 2 parentheses, negative 3, plus 3 parentheses, 1. And that equals 4 also. So this one is the solution. All right, that was a 3 by 3. Now this one is a 2 by 2. A 2 by 2 system of equations because it uses 2 equations and has 2 variables. All right, so it's going to have an x and a y and not a z because it only has x and y in it. All right, so we're going to check and see if A is a solution. So we're going to do 2 parentheses for x, we'll put 15, minus 7 parentheses for y, we'll put 3, equals 9, and that works. Okay, then we've got to check this one. Now this one's a little different because we have y equals, so we're really plugging in the 3 here for y and the 15 for the x. Okay, and what we're going to do is work this out and see if we get 3, if we get the y. So we'll have parentheses 1/2, parentheses 15, minus 3, or you could use 0.5 instead of 1/2, same thing. And that equals 0.4, not 3. Okay, so A is not a solution. I'm going to erase that so I don't get confused on the next one. Now I'm going to try B. So 2 parentheses 8 minus 7 parentheses 1, and that equals 9, which it's supposed to. Okay, and then let's see if 1/2 of 8 minus 3 equals 1. All right, so we'll do 1/2 in parentheses times 8 in parentheses minus 3, and that does equal 1. It does equal the y. So this is our solution. Okay, go ahead and stop the video and work 3 and 4. Take about 5 minutes and see if you can figure out which one of these is solution to number 3 and which one of these is solution to number 4. Notice that these are called ordered pair or ordered triples because there's 3 of them. All right, on number 3, you should have gotten A, and number 4, you should have gotten B. And 3 and 1 works in both of these, and negative 2, 4, 7 works in all 3 of those. Okay. Now you're going to work the same thing with what's called plug into the system. It's a little puzzle. We're going to evaluate each equation for the given values in the ordered triple. If the values check in the equation, then shade in the corresponding box. When all items are complete, the remaining boxes, which have not been shaded, will spell out a quote. Be sure to check each solution set for each equation. The equation will have more than one set that works. So in other words, we're going to take these 3 numbers and see if they will, if we plug them in for x, y, and z, we're going to see if it equals 14. So 3 parentheses, negative 2, plus 2 parentheses 3, plus parentheses negative 3. And that equals negative 3 and not 14. So this does not work, and it told us to only shade it if it did work. So I'm just going to put a little X so I know that I tried that and it didn't work. Okay, so now I'm going to go down to the next one and see if this works in here. So negative 2 parentheses negative 2 plus parentheses 3 minus 5 parentheses negative 3. And it does equal 22, like it does here, and so we will shade this one in. Okay, then I'm going to go ahead and work one more with you, this bottom one. And we'll see if it works. So 4 parentheses, negative 2, minus 3 parentheses 3, plus 2 parentheses negative 3, and I do not get negative 18, so this one does not work. Then you can continue doing all of these and all of these down here, You want to answer this question after you've done all of these boxes and answer this question after you've done all of these boxes. And then once you've done them all, you're going to go across and only write down the ones that are not shaded down here to answer this little puzzle. Okay, so go across and only write down in here the ones that are not shaded.